Let's take a look here at example number 2 from this section. Now, if we had been in class, we would have been able to have a little bit more fun with the question here, but we'll go ahead and just try to simulate kind of how this would have worked had we been in class. Let's suppose the following. Let's suppose that you are in charge of quality control at Mars, the company, not the planet. You take a random sample of M&Ms and you count the number of each color. Maybe the company has claimed previously that the distribution of colors is supposed to be as follows, right? Like this is maybe the percentage of M&Ms that are supposed to be brown and yellow and red and blue and orange and green, right? I could see the percentages here. Well, I could imagine then actually trying to go ahead and test at this company if these are the right percentages. Do the machines actually produce the appropriate percentage of brown and yellow and red and all the other different colors? Well, if we had been in class, I would have tried to give each of you your own bag of M&Ms to actually try to open it and sort it through and see if you could take that little sample and make a conclusion about if you think these percentages are correct or if maybe they need any adjusting. Well, we can go ahead and still pretend like we are able to do that here just to serve as another example. So I'm going to set up here my two different hypotheses. So here would be my first one. My first hypothesis, again, would be something like the percentages of colors are all correct. Right? All those percentages up there are perfectly fine. My alternative would be at least one percentage is not correct. Boom. Okay, so those are my two hypotheses. Either these are exactly the right percentages for the number of M&Ms or percentage of M&Ms that come out with each color, or they're not. Now, if I wanted to go ahead and test this, I would actually have to open a bag of M&Ms and observe what happens. So you could maybe imagine if you had a bag of M&Ms, you dumped them out on the table in front of you, you could start sorting them out into different color groups, right? Like isolate all the browns and the yellows and the reds and the blues, like you do normally every time you open a bag of M&Ms, because that is, of course, the right way to eat them. Now, let's just suppose here that I open a bag of M&Ms and I get something maybe like 15 brown M&Ms. Maybe I get 7 yellow. Maybe I get 16 red. Maybe there's 22 blue, 21 orange, and 23 green. So maybe in total, if I added all these up, maybe I had like 104 M&Ms. I think that's what that would total up to. Let's just use this as a pretend bag of M&Ms. It's a pretty big bag with 104. Okay, so what I could go ahead and try to do then is to take a look at, if this is what I observed out of a bag, what would I have expected to see? Now this is often the part where people are a little bit weary of how they compute each of these expected values, but keep in mind it's really easy. I expect 13% of my M&Ms to be brown, and since I have 104 M&Ms, if I expect 13% of them to be brown, I should take 104 and multiply by 0.13. If I was to go ahead and do this, 104 times 0.13 gets me this value, 13.52. And I'm actually going to write that entire value down, even the decimal. I'm not going to round anything, and I'm just going to put that. I observed 15. I would have expected 13.52. Notice that I can do the same thing as I move down the line. Over here, I would have done 104. M&Ms is what I have, and I expect 14% to be yellow. So if I multiply 104 by 14%, I think you could double check. I get the value 14.56. I'd ask you to go ahead and try to see if you can grab all the rest of the values. Pause the video right now if you need to. All right, so here's the values that I end up with. It's 13.52, 24.96, 20.8, and 16.64. Now, interestingly, if I added all these values together, I should still get 104. I still should have a total of 104 M&Ms I was working with. It's just I expected them in different quantities. And so now I can easily see that I have my observeds, I have my expected frequencies, and I can see the categories that are kind of pretty close. Like look at this orange category. Wow, I almost got exactly what I would have expected. And other categories, maybe like in yellow, are like pretty far off. Okay, let's go ahead though and run our checks just to make sure everything's good here. Check number 1 says, do you have a random sample? Well, let's assume yeah, because if I just got these numbers, say, from a bag of M&Ms, that's like a random selection. I could then also say, in number 2 here, all expected frequencies are greater than or equal to 1. Well, that's definitely true. I could say in number 3, no more than 20% of the expected frequencies are less than 5. Again, 0 of these 6 are less than 5, so that's 0%. So automatically I definitely know, yes, I have less than 20% that are under 5. Now, the last one again is sampling without replacement. I'm never going to take a M&M and determine its color and then try to determine its color again to re-record it in the list. So I'm going to have to do is 20 times 104 less than or equal to capital N. Let's see, 20 times 104 is going to be something like 2080. And if I had 104 M&Ms, what we're looking at here is a total number of M&Ms in existence more than 2080. And I go, yep, I've probably even eaten more than 2080 M&Ms in my lifetime. So that's not too surprising. All right, I can then get my chi-squared value and go ahead and run the test. Remember that my test over here is always going to be a right-tailed test. And I have my nice distribution curve that's skewed off to the right, and it starts at 0. I'm going to go ahead and run the test and fill in all the given information. So on my calculator, I would have to go back. I'm going to have to edit all these old values that are in here. And so I'll go and I'll clear out all of these lists. And then I can go right down the line and start typing in all of my different observed values. And then in the column over, my expected values. And I'm going to type those in, decimals and all. So let's see, 20.8, 16.64. Once I have these, I know I can run the test. So I'm going to go and run my chi-squared goodness of fit test. My L1 and L2 are both my observed and expected, but here I have to change my degrees of freedom. How many categories do we have? How many different colors were possible? Well, if you count them up, there should be 6. Remember, degrees of freedom is always number of categories minus 1, so this time I need 5. If I go to here and calculate, I can see that my chi-squared value is 7.3261. So I'll write that down, 7.3261. And I can go ahead and even put that down here on my number line, 7.3261. My p-value is then going to be my shaded space over here. And I know I can get that by simply doing the probability of chi-squared being greater than 7.3261. The calculator already told me what that value is. It's 0.1975 if I round. So 0.1975. My alpha on this particular question was given to me at 10%. So once my alpha is known to be at 10%, this becomes pretty easy to work with. I can now see that my sample is not rare. And so I immediately know how I would write out a conclusion. I would be able to write something down kind of like the following. I would be able to go ahead and state that it is not rare to get a chi-squared value of, of 7.3261 if the percentages given are all correct. So we have no reason to doubt that all the given percentages are correct. There doesn't seem to be any reason to doubt that H0 is okay. Now, it doesn't, again, absolutely confirm that H0 is true. It's just based on the evidence that we have from our 104 M&Ms. This is our best guess about what's going to happen with all the M&Ms. So if you had your own bag of M&Ms, you might have been able to reach a slightly different conclusion based on what you would have seen. But hopefully this gives you the idea of how we can work through this in a variety of other sorts of questions. Example number 3 in the notes is left as one for you to go ahead and try on your own. And of course there is a worksheet available with a bunch of other questions. And I'll leave that to you. If you have questions on this section, of course, please let me know via email or in office hours.